Have you ever wondered how spacecraft endure the harsh conditions of space? It's a question that takes us to the frontier of materials science, where innovation and ingenuity collide. You see, space is a hostile environment. It's a realm of extreme temperatures fluctuating between intense heat and chilling cold. It's a sea of radiation with cosmic rays and solar flares constantly bombarding anything that dares venture beyond Earth's protective atmosphere. And let's not forget about micrometeoroids, tiny particles zipping around at incredible speeds, capable of causing significant damage to spacecraft. To navigate these challenges, we turn to materials science, a field that explores the properties and potential of different substances. It's a realm that's constantly evolving, pushing boundaries and enabling us to reach further into the cosmos. This is where the magic happens, where we craft the tools and technology to survive and thrive in the void of space. So, are you ready? Let's delve into the exciting world of materials science for space exploration. Radiation is one of the most significant threats in space. So how do we protect astronauts and spacecraft from this invisible foe? Well, it's all about the right materials, specifically radiation-resistant alloys. These are special metallic mixtures designed to withstand the onslaught of harmful space radiation. Picture these alloys as invisible shields, absorbing and deflecting radiation, helping to keep our astronauts and space technology safe and functional. So, what's the science behind these alloys? Fundamentally, it's about the atomic structure. These alloys are crafted with a lattice structure that can absorb high-energy particles, such as those found in cosmic radiation. When these particles strike the alloy, they displace atoms within the lattice, and it's this displacement that absorbs the energy of the incoming radiation. But it's not just about absorption. These alloys also have the ability to deflect radiation. It's a bit like how a mirror reflects light, bouncing it away. The combination of absorption and deflection makes these alloys a formidable barrier against the harmful effects of space radiation. Let's take a real-life example. The International Space Station, ISS. Orbiting around 250 miles above Earth's surface, the ISS is constantly bombarded by space radiation. The walls of the ISS are made from a radiation-resistant alloy that contains aluminum. This alloy is not only lightweight, crucial for launch, but also has a high resistance to radiation, making it the perfect choice for the ISS's protective skin. However, the journey doesn't end there. Scientists and engineers are continually searching for new and improved radiation-resistant alloys. The ultimate goal is to create materials that can withstand even the harshest space environments, allowing for longer and more ambitious missions, like manned voyages to Mars or even beyond. With these radiation-resistant alloys, we can shield astronauts from the harmful effects of space radiation. And it's not just about protection, it's about pushing the boundaries of what is possible, enabling us to take the next giant leap in space exploration. From our last discussion about radiation-resistant alloys and heat-resistant materials, we know that the right materials can make or break a space mission. But let's zero in on a particular type of space technology that we often take for granted: satellites. These unsung heroes of space exploration are a testament to the power of materials science. Satellites, whether they are weather, communication, or navigation satellites, all depend on materials science for their design and operation. The materials used in satellites must withstand the harsh conditions of space, including extreme temperatures, space radiation, and the vacuum of space. So, what kinds of materials are we talking about? Well, many satellites are made from lightweight yet strong materials like aluminum and titanium alloys. These materials are chosen for their strength-to-weight ratio, which is crucial when you're launching something into space. Every gram counts. Plus, these alloys are resistant to the corrosive effects of the space environment. But it's not just about the satellite's body. The solar panels, which provide power for the satellite, are often made from gallium arsenide, a compound that's more efficient at converting sunlight into electricity than traditional silicon. And let's not forget about the thermal blankets that wrap around satellites. These are made from multi-layer insulation, which reflects heat and helps regulate the satellite's temperature. However, materials science in satellite technology is not without its challenges. Space debris, for instance, poses a significant threat to satellites. To combat this, scientists are exploring materials that can withstand impacts from space debris, like Kevlar and Nextel, which are used in bulletproof vests and firefighter suits, respectively. They're also looking into self-healing materials that can repair themselves if damaged. So, the next time you check the weather forecast or use your GPS, take a moment to appreciate the role of materials science in satellite technology. With the right materials, we can ensure that our satellites continue to orbit and provide us with invaluable data and services. And who knows what new materials we'll discover in the future. As we've seen, the frontier of materials science is always expanding. Space is a place of extremes, from the freezing void to the scorching heat of re-entry. How do spacecraft survive these temperature extremes? Let's dive into the fascinating world of heat-resistant materials that make this possible. When we talk about space travel, one of the most challenging aspects is protecting the spacecraft and its inhabitants from the extreme temperatures encountered during re-entry into Earth's atmosphere. The spacecraft can experience temperatures exceeding 2,000 degrees Fahrenheit. At this heat, most materials would melt or burn up. So what's the secret? It's all about the materials used, specifically the thermal protection systems, often made up of heat-resistant materials like the thermal tiles on the space shuttle. These aren't your average kitchen tiles, though. They're made from a type of silica fiber compound, which is incredibly lightweight, yet can withstand extreme temperatures. These tiles work by insulating the spacecraft, keeping the heat of re-entry from reaching the interior. They achieve this through a process known as ablation, where they absorb the intense heat and then slowly release it. The outer layer of the tile gets so hot it turns to gas, taking the heat away with it. This process helps to keep the spacecraft's interior at a safe temperature. But how do we make these tiles? It's a complex process. The tiles are initially made from a type of glass filled with tiny air bubbles, making it a great insulator. This material is then exposed to high temperatures to increase its heat resistance. It's a process that requires precision and expertise, but it's essential for protecting spacecraft and astronauts. Of course, heat-resistant materials are not just about re-entry. They also play a crucial role in protecting spacecraft from the intense heat of the sun when they are in space. Without these materials, spacecraft would quickly overheat, damaging their delicate instruments and making space travel impossible. Thanks to these heat-resistant materials, spacecraft can endure the fiery re-entry into Earth's atmosphere. So next time you watch a spacecraft launch or re-enter the Earth's atmosphere, remember the incredible materials science that makes it all possible. From the harsh and unpredictable conditions on Mars to the extreme temperatures and pressures that rovers must endure during the journey, materials science plays a crucial role in our quest to explore the red planet. Let's delve into how materials science propels these incredible feats of engineering. Mars presents a unique set of challenges. Its thin atmosphere, extreme temperature swings, and a surface strewn with sharp rocks and dust storms are all elements that Mars rovers must withstand. So, how do we design these rovers to survive such harsh conditions? It's all about the materials. One of the key materials used in Mars rovers is titanium. This metal is chosen for its strength and lightness. It's also highly resistant to corrosion, which is essential given the high amounts of perchlorates, a type of salt that can be corrosive, in Martian soil. The wheels of the rovers are made of aluminum, chosen for its durability and lightness. They are designed to be flexible, to better traverse the rocky Martian terrain. The body of the rover, meanwhile, is covered in a gold film. This isn't for aesthetics. The gold is an excellent reflector of infrared radiation, helping to regulate the rover's temperature. But it's not just about surviving Mars. The rovers also need to survive the journey there. This is where heat-resistant materials like those used in spacecraft re-entry come in. These materials protect the rover during the descent and landing on Mars, where it experiences intense heat. Looking ahead, materials science will continue to play a key role in our exploration of Mars. From developing new alloys that can withstand Mars's unique conditions, to self-healing materials that can autonomously repair damage, the possibilities are endless. Thanks to materials science, the red planet is within our reach. As we continue to push the boundaries of what's possible, one thing is clear. The future of Mars exploration will be forged in the crucible of materials science. So, next time you see images from a Mars rover, remember the incredible materials science that makes it all possible. In space, even tiny micrometeoroids can cause catastrophic damage. So how can we repair spacecraft millions of miles away from Earth? Let's dive into the fascinating world of self-healing materials. Imagine if our skin's ability to heal itself after a cut could be replicated in materials. That's exactly what scientists have done. And it's not science fiction. At the core of this innovation are polymers, long chains of molecules that can be manipulated to have different properties. Some clever chemists have created a type of polymer that, when damaged, can repair itself. This is achieved by embedding tiny microcapsules filled with a healing agent into the material. When the material is damaged, these capsules break open, releasing the healing agent, which then reacts with a catalyst in the material to fill in the damaged area, much like our blood clots to heal a wound. These self-healing materials have huge potential in space travel. In the cold, harsh expanse of space, even the smallest of micrometeoroids can cause significant damage to spacecraft. It's not like we can simply send a repair crew out to fix the damage when we're millions of miles away from Earth. But what if the spacecraft could repair itself? Self-healing materials could be the answer. A spacecraft equipped with self-healing materials could autonomously repair damage caused by micrometeoroids, ensuring the longevity and safety of the spacecraft during long-duration missions. Imagine the possibilities. We could have spacecraft that are more resilient, able to undertake longer missions, and explore further into the unknown. We could even envision a future where these materials are used in the construction of lunar or Martian bases, providing a safety net for our astronauts venturing into the final frontier. The realm of self-healing materials showcases the elegance of marrying chemistry with space technology. It's an exciting field that's pushing the boundaries of what's possible, and it's just one of the many ways that materials science is shaping the future of space exploration. With self-healing materials, we can ensure the longevity and safety of spacecraft during long-duration missions. From self-healing spacecraft to radiation-resistant alloys, materials science plays a crucial role in space exploration. But there's one more place where materials science is making a difference, and it's closer to home, or rather, to the astronaut. Yes, we're talking about spacesuits. These aren't just garments. They're mobile life support systems designed to protect astronauts from the harsh realities of space. Materials science is at the heart of spacesuit design and function. Each spacesuit is a marvel of engineering, combining various materials to provide oxygen, remove carbon dioxide, regulate temperature, and shield the astronaut from radiation. Consider the outermost layer of the spacesuit, a material known as orthofabric. It's a blend of 3 different materials: Gore-Tex for its breathability and water resistance, Kevlar for its strength and flame resistance, and Nomex for its capability to withstand high temperatures. This combination provides the robustness needed to endure space's harsh conditions. But what about the future of spacesuits? As we venture further into the cosmos, our spacesuits will need to adapt to new environments. This is where materials science shines. Scientists are exploring self-healing materials for spacesuits, capable of repairing micro-tears caused by micrometeoroids. They're also investigating materials that can shield astronauts from harmful cosmic radiation during deep space missions. Next time you see an astronaut, remember it's not just a human in a fancy outfit. It's a testament to the power of materials science, keeping our space explorers safe as they push the boundaries of human knowledge. So, as we look towards the future, we can be assured that materials science will continue to play a pivotal role in our quest to explore the great beyond. We've covered some cutting-edge materials for space travel, but what does the future hold? It's a thrilling question, one that leads us to the frontiers of nanomaterials and biomaterials. These aren't just futuristic buzzwords. They're the keys to revolutionizing space travel and making our sci-fi dreams a reality. Let's dive in, shall we? Nanomaterials, as the name suggests, are incredibly tiny, but don't let their size fool you. They pack a punch, offering superior strength, flexibility, and lightness compared to traditional materials. Imagine a spacecraft as strong as steel, but as light as a feather. That's the potential we're talking about. Then we have biomaterials. These are materials inspired by or outright borrowed from nature. Think of spider silk, one of the toughest materials known to man, or the regenerative capabilities of starfish. These natural marvels are inspiring scientists to develop materials that can self-repair, adapt to harsh environments, and even recycle waste into useful resources. Imagine a spaceship that can heal itself after a meteor impact, or a Martian habitat that uses native bacteria to turn carbon dioxide into oxygen. Sounds like science fiction, doesn't it? But with the rapid advancements in biomaterials, it's not as far-fetched as you might think. In fact, the future of materials science could very well lie in the combination of these 2 fields. Imagine nanobots repairing a spacecraft, or a spacesuit made from a nano-enhanced biomaterial that can adapt to different planetary conditions. The possibilities are as boundless as space itself. And that's precisely the point. For humanity to thrive beyond our home planet, we need materials that can withstand the rigors of space and make long-duration missions feasible. The future of space travel is bright, thanks to the ongoing advancements in materials science. We're not just dreaming of the stars anymore, we're building the materials to get us there. And who knows, the next great leap in space exploration could be just around the corner, waiting for us in a lab or a cleverly designed molecule. The future of space travel is bright, thanks to the ongoing advancements in materials science. Living in space is a dream for many, and materials science is making it possible. As we transition from the realm of space exploration to space habitation, the role of materials science becomes even more crucial. It's not just about building a spacecraft that can withstand the journey. It's about creating habitats where humans can live and thrive outside our home planet. Space habitats, or what some might call off-Earth homes, are complex structures designed to protect humans from the inhospitable environment of space. The materials used in their construction must meet a variety of stringent requirements. They must be lightweight for transport yet strong enough to withstand the intense radiation, extreme temperatures, and microgravity conditions of space. This is where advanced materials like radiation-resistant alloys, heat-resistant ceramics, and self-healing polymers come into play. But it's not just about protection. These habitats also need to provide a comfortable living environment. The materials used must be able to regulate temperature, manage waste, and even recycle resources. Imagine a space habitat that uses biomaterials to convert carbon dioxide back into breathable oxygen, or nanomaterials that can self-repair minor damages, reducing the need for maintenance. Looking to the future, the role of materials science in space habitation becomes even more significant. With the advent of 3D printing technology, we're looking at the possibility of using local resources to build habitats. On Mars, for instance, scientists are exploring the use of Martian soil to create building materials. This is a game changer as it reduces the need to transport heavy construction materials from Earth. In conclusion, the dream of living among the stars is closer than you think, thanks to materials science. It's not just about getting us to space, it's about allowing us to stay there. And with the ongoing advancements in materials science, our dream of building homes beyond Earth is becoming a reality. As we continue to push the boundaries of space habitation, who knows what exciting materials we will discover next? In the vast expanse of space, materials science stands as our shield and sword. It protects us from the harsh conditions and enables us to explore further. Today, we've journeyed through the frontier of materials science, delving into the world of radiation-resistant alloys, heat-resistant materials, and self-healing substances. These marvels of modern science aren't just hypothetical. They're paving the way for long-duration missions and even colonization on distant celestial bodies. The importance of these materials cannot be overstated. They are the backbone of our interstellar ambitions, the key to unlocking new frontiers in space travel. Every day, scientists and engineers are pushing the boundaries of what's possible, creating materials that can withstand the harshest environments known to humanity. If you're as excited about the future of space travel as we are, make sure to subscribe to Brainiacata. Stay curious, stay informed, and as always, keep looking up to the stars.